Okay, let's see. So we're still working the same example. Oh, so we're graphing. Okay, so now that we have it in standard form on this line, we can actually graph it from there. Because this is really our f of x equals a x minus h squared plus k. So if we're going to use this line, what's our h and our k? Our h comma k, h should be x minus h should be 1, and then the k is going to be negative 4 by 3. Okay. So these should be the coordinates of our vertex. So then we can use that to graph it, really. And let's get a copy of the original. Okay. So where did we go? What? Anyway. Okay. All right. So the axis is symmetry. So h comma k is 1 comma negative 4. So let's graph this over 1. And notice the parabola opens upward over 1 down. So I'll do this. This is the positive x. This is our positive y. Let's see. So h comma k is 1 to the right and down 1 and a third. So we'll make this 1, 2, 3, 4, 1, 2, 1, 1, 2. Okay. So then over 1 and down 1 and a third. So over 1, 1, and 1/3 is about here. So this should be our vertex. And if we look at the original, the leading coefficient is positive, which is 3 in this case. So which way should it open? It should open upward. So we have our axis of symmetry. Right? Here's our axis of symmetry. Then we're just going to choose points on the left and right. Now we could plot those intercepts, which is fine. It'll work. Just for the sake of time, I'm just going to try to keep it simple. So now 1 to the right, what x value am I going to be at? I'll be at 2. So if I plug 2 into the original, that's going to be 12. Minus 12 is 0, should be negative. Sorry, 2. So when x is 2, 2 squared is 4, that's 12. And that's 12, so that's 0. So then that's negative 1. So then when x is 2, y is negative 1. Okay, so if we get 1 to the right, we'll automatically get 1 to the left. So when x is 0, the y should be negative 1, and that indeed checks out. So let's do when x is, let's do negative 1, just for a difference. So then when x is negative 1, if we plug negative 1 to the original, that's going to be a positive, so that's 3. Double negative becomes positive, so that's 9. Minus 1 is 8. Oh, that goes off my chart. 1, 2, 3. Yeah, that goes off my chart. All right. So then if we connect these with a smooth curve, 1, 2, 3, 4. So it just needs to go off the graph before I reach that point. Something like that. All right. That's essentially it. I mean, we identified our vertex and we chose a few additional points. We made it clear that the graph goes off the coordinate plane. That's not major, but the main point was the vertex, the axis of symmetry, and a few additional points on either side of that vertex. whenever you get a point on the right, you automatically get a point on the left. So that's a crude graph. I could use a few more points to make it better. So we have a crude graph, and then it asks to solve when is this polynomial less than 0. So now, before we've done this a couple of times too. We'll have a quadratic that's less than or equal to 0. So then we'll find the zeros. We'll get these x-intercepts, and then we'll plot them on a number line and choose points between and beyond all of these points. It keeps breaking ours up into 3. And we've discussed this, but if you look at this, this is saying when is this polynomial less than or equal to 0? Okay. So looking at the graph, it's less than or equal to 0 between the x-intercepts. So then to answer the question, the inequality is going to be negative, we're going to have 1 minus 2 by root 3, and then 1 plus 2 by root 3. Oh, sorry, we're talking about interval. So then, because it's greater than or equal to, right here, because it can be equal to 0, that means our result is going to use square brackets, which means we can include those endpoints to get our zeros. So then this will get a square bracket, and this will get a square bracket. Okay, I kind of want to verify, because just because these numbers aren't clean, I want to verify that these are actually on my parabola. Okay, so I will put in my original, go to y equals and clear. It's going to be 3x squared minus 6x minus 1. And our window, that should be fine for now. Cross that -1, then the vertex, then up. Okay. So it's below the x-axis between those intercepts. So then what I want to do, I want to go to like stat. I want to edit the first one, and I want to plot my point. So like my intercepts, my first one is 1 minus 2 divided by the square root of 3. 1 minus 2 divided by the square root of 2, square root of 3. Okay, so that's my first x-intercept. So if that's my x, my y is 0. And then my other one, I think it's going to be 1 plus 2 divided by the square root of 3. That's another one of my x's. And I want to plot, and that should give us that y is 0. So then I want to go up here to stat plot and turn it on for L1 and L2. And then we should see those points plotted onto the graph. So I'm going to give it some time to warm up. I might have to reset it. Let's see, let's try stat plot again. Plot is on. Not it turned on. Uh-oh, am I not able to do it? Oh, there we go. Okay, we got it. Now when I go to the graph, yeah, it went through both of our points. Yep, these are good. Okay. Okay, so this one should be okay. And then, you can actually find those numbers. We actually have it here in the stat. So negative, which is approximately negative 0.1547 to 2.1547.